Alright, I wanted to give you guys an opportunity to watch the lesson that you'll be going over with the substitute online if you wanted to again. We are on notes number 7. And we're actually covering 2 lessons out of the book. We're going to talk about the intro to solving equations. Just note that I do know how to write my letters correctly, but sometimes I can't do it with this program, so I have to go backwards. Now this comes out of lesson 1-7, and then we're also going to be talking about formulas, which comes out of lesson 1-9. Okay? Remember, so far in this chapter we've been exclusively studying expressions, so we're now jumping ship and starting to talk about equations. So let's define an equation. Now this one we're going to call a mathematical sentence. And just like in English, that means it's a standalone thought that uses the key thing and equal sign. Let's highlight that for you guys. Okay. Now, equations break down into 2 groups. The ones that you've studied when you were littler, and those are called a numerical sentence. And you could probably take a guess at the numerical that means numbers, and that would be absolutely right. So numerical sentence contains numbers only. So now that's kind of a misnomer because it does contain operation symbols and does contain equals, but there is no variables involved. Now, interestingly enough, about a numerical sentence, people can write numerical sentences incorrectly, so what's on the left doesn't equal on the right, or that they can be, so they can be either true or false. So here's an example of each. A true one would be something like 7 minus 2 equals 5, and so the proof is, yep, what's on the left equals what's on the right, so you say true. And a false one, you have 5 plus 3 equals 2, and that actually gives you 8, which doesn't equal 2, so you say that is false. And so what happens in these false numerical sentences is that basically somebody sees the numbers, does math, but doesn't do the math that it tells you to do, just common mistake kind of things. Okay? Now, when we have variables involved, we now call that an open sentence. So that's going to be an equation containing at least one variable. And the problem with open sentences, we don't know if they're true or false unless they tell us what the variable equals. So they could be true if we have a value for the variable that makes the left side equal the right side, and they'll be false if we have a value for a variable where it's false on one side, true on the other. So again, we can't process what kind of answer we're going to get unless they give us further information. Now, generally speaking, that further information that we get is called a replacement set. So in the given problem, they're going to tell you, hey, I want you to substitute these numbers in for the variable and solve it out and tell me what you get. Okay? So it's a given set of numbers to, and I'm going to use the word, replace a variable in an open sentence. Okay, so again, replacement set is a given set of numbers to replace a variable in an open sentence. Now, from this list that they give you, what we're looking for is the one or however many that will make a true sentence. That number that, or numbers that gives us a true sentence, is called a solution. So that is a value for a variable that makes the equation true. Okay. Now sometimes there's more than one right answer, so if you have, more than one correct answer, we now have what's called a solution set. And those are all solutions to a problem. And when you have more than one answer, you put them I'm sorry, I'm having a hard time here. You're going to use the braces. Sorry, I'm going to have to tell you that those are braces because my writing, this pen is a little bit of a challenge. So put answers in braces. Now, if there's only one answer, then you say variable equals answer. Okay? Alright, so let's do some problems like this. And the directions are going to say, tell whether each sentence is true, false, or open. So they're going to give you a sentence, and there's going to be math to be done. And basically what we're trying to do is to figure out, does the left side equal the right side? So we just go ahead and solve it, following order of operations. So 4 times 2 is 8, and 8 plus 3 is 11. Since 11 equals 11, we say that's true. Alright, well what about 4 times 2 minus 3? Will that give me the answer 3? So again, we just solve it out. 4 times 2 is 8. 8 take away, there's my brain always trying to get the answer. 8 take away 3 is 5, and 5 doesn't equal 3, so we say it's false. Now here's the great thing about any equation that contains a variable. It either could be true or false depending on what x is, so that's when we say the answer is open. So that's the first 3 problems off your homework are going to be like that. Now, the next problem deals with a new set of directions that say solve for the given replacement set. There we go. And they're going to give us an equation. We've got 3x equals x over 2, or 1/2 x, plus 5. And then you'll see the word 4. And then here come my lousy braces. And you'll see some numbers in our case we have 3 numbers. And here's what we have to do in this problem. You're going to have to plug in every single number into the equation and test it. And we're looking for true answers. So answers that make the equation true. If we have get a true straight away, don't just throw it out. You're going to have to show me work on every single one of them. So we start by replacing or substituting in one number at a time. So we're going to start with 0. So 3 times 0. And we're going to figure out if that's the same as 0 divided by 2 plus 5. So again, this is our big question mark. So we just start doing math. 3 times 0 is 0. 0 divided by 2 is 0. Write out the rest of the problem. 0 plus 5 equals 5. Since 0 doesn't equal 5, this is false. So 0 is not a solution. Okay? And again, what we're looking for are solutions. So now let's try 1. Every time I see x, I'm going to substitute in 1. And again, we're questioning if what's on the left equals what's on the right. For some reason, kids like to forget the plus 5. But remember, every piece needs to be represented. So 3 times 1 is 3 equals 1/2 plus 5. So I get 3 and 5.5. Well, they're not equal, so that one's false. So guess what? 1's not a... Oops, that was supposed to be red. Let's try that again. Sorry about that. 1 is also not a solution. So we have one more, and sometimes none of them work. So don't be all thinking it's going to have to be one in that group, because it isn't always. So now we're going to replace x with 2. Everywhere we see x, we're going to replace it with a 2. So we don't know what we're going to get here. And so we do our math. So we get 3 times 2 is 6. 2 divided by 2 is 1. 1 plus 5 is 6. Finally, we get something that's true. So what we say is the solution, solution set is 2. Now, I can write it that way, or I could have written it as x equals 2. Both of those are acceptable answers. Alright, so here's another way that we're going to be dealing with this idea of equations, is we're going to be asked to create equivalent equations. Okay, to do that, you're going to, I'm going to just do some other colors. I'm getting kind of bored of a lot of black. Treat each side of the equation the same. So what that means, you're going to perform the same math with the same number on both sides of the equals. So here's how this is going to play out in your homework and also on your test. Directions are going to say what was done to the first equation Oh, I am having such trouble. Alright, hold on a second. Okay, let's see if this pen works any better than the last one. So what was done to the first equation, oops, try that again. To get the second one. So basically what you're going to do is be a math detective. So if you look, your original equation is x plus 2 equals 7. Then the new equation becomes x plus 7 equals 12. So your job is to try to figure out how did x plus 2 equals 7 become x plus 7 equals 12. Well, generally speaking, where you want to look is in the part of the equation where there's just numbers only. So for example, look on this right side. We have a 7 that became a 12. So you ask yourself, well, what could I do to 7 to make it 12? And we come up with a guess, a hypothesis, that if I added 5 to 7, I would get 12. So what I want to do is test this hypothesis on the other side. And if adding 5 to the left side of the equation gives me the new left side, then that's what I'm going to do. So x plus 2 plus 5, so 2 plus 5 is 7, and that's exactly it. So your answer is add 5 to, and this is the crucial part, both sides. Equations are about fairness, and you got to treat both sides fairly. Okay? Alright, so that kind of concludes the lesson 1-7. Let's talk about 1-9 and what is a formula. We talked about this a little bit in our notes on Friday. And formulas are, it's an equation, or let's make it just formula. It's an equation that shows a relationship between two or more variables. Alright, so what we need to learn to do is to evaluate. So how we go about evaluating a formula. In other words, we're going to replace values in for those variables and do the math. So we're going to substitute given values into the corresponding variables, meaning in the problem they say let radius equal 1.5 inches, and so on and so forth. Given values, variables, and then solve for the remaining unknown value. Now, traditionally, the variable that was by itself is what you guys have been solving for, but as you've gotten into higher math now, we're going to have you solve for a piece with math being done to it, and you already know the answer on the other side. So, for example, one of the formulas we talked about the other day was area. And so area of a rectangle is length times width. So more along the lines, what you're going to be doing is you're going to know what the area is, and you're going to know the length, and your job would be to calculate the width. When you were in elementary school, they gave you the length and the width, and your job was to figure out the area. Okay, so let's do a little bit of memorizing if you don't already know these. So these different formulas are important to know. Perimeter of a rectangle, we talked about that one. The more formulas you know, the faster the math is going to be. And that one is P equals 2L plus 2W. We have the we talked about the area of a rectangle. Was A equals L times W, length times width. Let's talk about area of a square. That's going to be area equals length of a side times itself. Perimeter of a square. P equals 4S, since all 4 sides have the same measurement. And then the last one we talked about was distance. And that's D equals RT, where D is the distance, R is the rate, and T is the time. And we also talked about some other basic calculations. Now, I'm going to give you one more piece that is crucial that you pay attention to, and if you don't, you're going to get questions wrong. And that deals with this concept of dimensional analysis. And dimensional analysis is you use conversion ratios to get dimensions to match. So in other words, you can only multiply like things together. It's kind of like when we were talking about combining like terms, how when you add, you only add the coefficients, the variables don't change. It was like if you added 3 kittens and 2 kittens, you don't get 5 puppies. You get 5 kittens, so the variable is not going to change. Same thing here. You can't multiply or do any math when the labels don't match, because that won't make sense. So you have to be very cautious. So I've got one problem for you to do, and I'm going to demonstrate that very skill, and guarantee it's going to show up on the test. Directions will say solve, and then here comes your problem. And this is very typical what you see at this point. Find the volume. And then it pauses and puts in parentheses V, so it's telling you that's the variable we're going to use to represent volume, of a toy box with length, and then they're going to stop and put in parentheses L, so you know that variable represents length, of 4 feet, width, and then they're going to stop and put W in parentheses, letting you know that's W represents a width of 24 inches, and height and then they're going to use H to represent the height of 30 inches using the formula V equals L times W times H. Okay, actually let me change it back to the way that they wrote it. They use lowercase letters. Same difference. So if you notice, you've got one dimension, and that would be your length. That's in feet. And then your next dimension, which is your width, was in inches. And then your next dimension, which was your height, was also in inches. Okay. So what we have is a couple of options. We can change everything to the smaller label inches. The only issue that will come up in our problem is that we'll have larger numbers to multiply with. But if we go to the higher label, feet, we may end up with fractional answers. But that's what I'm going to do, is I'm going to go to feet. So remember we talked about we're going to use this conversion ratios. So we need to know the conversion ratio between feet and inches. So the one I want the answer to remain in, which in this case is feet, is going to go on top. The variable, or the label I want to get rid of, goes on the bottom. So I know that in 1 foot there's 12 inches. So we're going to go ahead and the inches cross out, and 12 goes into 24 twice, and that gives me 2 feet. And then again the inches will cross out. And here's the problem with this one. 30 is not evenly divisible by 12. So what do they have that you can factor out? Well, they have a 6 in common. So if I reduce both by 6, 30 divided by 6 is 5, 12 divided by 6 is 2, and I get this. Now, before you start panicking about fractions and wanting to change them to decimals, don't. So let's go back to our formula, and we get V equals length, and I'm going to just keep the dimensions in here, times the width, which is the 2 feet, times the height, which was 5/2 feet. So what we're going to do is see if there's any simplifying that can take place, and if you notice, this 2 goes into itself once and into this 2 once, and I'm left with 4 times 1 times 5, which is 20, and in the denominator all there is a 1, so I don't include it. And then here's the thing you need to understand about volume. How many times did feet show up? Well, if you notice, it showed up once, twice, 3 times. So that's what we add to our label to represent cubic feet, and that's our answer. If I don't get all the labels to match, I won't be able to do the math accurately. All right, that's it. Good luck.